Today we're going to model trig functions, and we're going to use them to find the temperature fluctuations throughout the year in Toronto, Ontario. So the information we're given is that the average monthly temperature in Toronto is 8.6 degrees Celsius, and that if we look at the average temperature for each month throughout the year, it fluctuates to a maximum of 13.1 degrees above the 8.6, and it fluctuates down to a minimum of 13.1 degrees below the 8.6. And we also know that the coldest month is January, which we'll just call month 1 in a 12-month system. And the hottest month is July, which is going to be month 7. Now we're giving each of the months numbers because I don't want my graph to have, an x-axis with January, February, March. I want it to have an x-axis with 1, 2, 3. So let's see if we can model this in Desmos using just that information. So I'm going to set up my function, and I'm going to use T at M to represent temperature at month. And I'm going to do that as a cos function. You always have the option of using sine as well, but cos is usually easier. Oh, I should change that to an M. It doesn't like it when you change variables mid-function. And we're going to have to play around with some information a little bit. So first thing I'm going to do actually is change my scales. And since we're looking at fluctuations throughout a year, you'll notice, sorry, I'm already in degrees. That's a good thing. Since I'm going over a year or 12 months, I'm going to put this between 0 and 12 months, and I'm actually going to put between -2 and 14, just a little above and a little below, so I'm not cutting off the good information at the edges of my graph. And I'm going to go up by ones, so each month will be on there. And then for my y-axis, I'm going to go down. I should have at least the maximum minimum temperatures on here. The maximum temperature is going to be 8.6 plus 13.1. So that would be 21.7. Just to be safe, I'm going to go up to about 24. And the minimum temperature is 8.6 minus 13.1, which is -4.5. I'm going to go down to, let's say, -10, just to be safe. Maybe -8's enough. Yeah, I think that'll work nicely. You know what? I'm going to make my top y value a little bit bigger just because I noticed at the top of the graph, the last number visible is 20. I want maybe 25 to be visible, so I'm going to do that. And I think that should work. Okay, so what information we have? We know that the average temperature throughout the entire year is 8.6, and that's going to actually be our C value. That's the middle temperature. And we want it to fluctuate. Oh, let's do a couple other things. Right now, this does not look like a cosine function. It looks almost linear. And the reason for that is because it's got a period of 360, and we're only showing between like 0 and 12. So I'm going to change the period. And the k value, the number in front of the x here, is always going to be 360 divided by whatever period I want. And since this is annual temperature fluctuation by month, I'm going to do it as 12. So it's going to convert over 12. And that means that whatever the temperature is here, which is of course not correct yet because we haven't filled in a whole bunch of other variables, it should go back to that temperature 12 months later. Okay, so we've got the period correct now. We've got the C value correct. What we need is the amplitude. Well, this is nice. We don't even actually have to calculate it. We know that it's going to be 13.1 above the average or 13.1 below. That means the amplitude is 13.1. Okay. I am, just for the heck of it, going to put y equals 8.6 on here, just so it's really clear where the middle line is, where the average temperature through the year is. Not that that's a big deal, but that's something that I think is worth mentioning. The last thing I want to do, or the only variable we haven't figured out yet, is the D value or the phase shift. And we're told that the hottest month occurs at 7 or July. Okay, so if the hottest month is here, this is where I want my maximum over at 7. Right now the peak is at 0, so I can move it over 7 units to the right, and it should be in the right spot. So I'm going to do -7 to move it 7 to the right. And sure enough, my temperature there is, it's maximum in July, it's minimum in January, which is month 1. That's it. We've found our whole model. I think that's all we have to do there. So those are our variables. Again, I could put this value here, 360 divided by 12 in lowest terms. It would just be 30. However, I find it is one time, the one and only time I can think of where I don't put fractions in lowest terms. And the reason for that is when it's in this form, I can quickly read off that the bottom is 12, which means that the period is 12. So I don't mind leaving that fraction in that form. Going back to the question for just a moment, the one other thing we wanted to find was use the model to predict the average temperature for March. Well, March is the 3rd month, January, February, March. So we'll go back over to our graph. And we want the month, which is the x equivalent, or it's on the x-axis. Technically, we're calling it the m-axis, but we'll say we want it when x is 3. And then I just look at what the value is at x equals 3, and it looks like it's about 2.05 degrees Celsius. So that would be our answer for that. And that is all there is to modeling temperature.